All right, you guys, I'm back with another video. This one is covering week 1, lesson 4, molar mass of elements lab. This is going to be helpful if you didn't finish this lab, you have any questions on this lab, or you never even started this lab, okay? So this beginning part here kind of walks you through some stuff about zinc, some background into units that we use for zinc. So you have to dig up some information from the periodic table to answer those questions. By the time you get down to number 5A, after reading that long paragraph, you should know that there are 65.39 grams per mole. Okay, it tells us to convert our units into grams per mole. And then what does that mean? That really means that I have 65.39 grams for every 1 mole of zinc that I have, okay? So now we can use that information to make a conversion factor. In 1 mole of zinc, there are 65.39 grams of zinc. And that info, that 65 number, if you haven't gotten it already, comes from the periodic table. Sorry, I'm looking for my Schoology here. If you go to my general resources folder on Schoology, you can find our periodic table that we use. And when I look for zinc, I find that it's right here, and it has that number 65.39. That's its atomic mass. Okay, so that's how we got that. Now we can use that in conversion factors. So just like we do with our regular conversion factors, we can go either way with that grams on top or moles on bottom, but no matter what you do, the 65.39 always goes with the grams and the 1 goes with the mole. So you can flip it either way you need, depending on how you want to cancel units. Now we have conversion factors that we can use in dimensional analysis to go from moles to grams and grams to moles. We call this number, any number that has the units of grams per mole that comes off the periodic table, we call it a molar mass. So the molar mass of zinc is 65.39 with the units of grams per mole. Okay. All right, you can answer these. I just helped you out with those. Now it says, now it's time to do something with all this information. Go to the balance and mass out 1 mole of zinc. I took a picture of what 1 mole of zinc looks like over here. Okay, 1 mole of zinc, you guys, is 65.39 grams. So that's exactly or almost how many grams are in this cup right here, okay? Now it says, now go to the balance and measure about 15 grams of zinc. So this is 15 grams of zinc, okay, about 15. All right, I think I massed out 16.02 grams of zinc, so I was close to 15. All right, it says compare this sample visually to your reference sample. Based on your observations, would you expect the 15-gram sample to be equal to 1 mole, more than 1 mole, or less than 1 mole? So you can see how much is in this cup versus how much is in this cup, and then circle which choice you think. Letter D says using dA and molar mass, calculate the number of moles of zinc from the number of grams of zinc you had in 7B. So in 7B, we had 16.02 grams, okay? So this says it's dA, so we need a start, an end, and a conversion factor. Your start is going to be a number and a unit, so that's at 16.02 grams. Your end is that unit it's looking for. It wants us to get it to moles. And our conversion factor is going to come from up here. You'll have to choose which one you want based on what units you want to cancel when you set up your problem, okay? But the point is that 1 mole of zinc equals 65.39 grams of zinc, okay? Your conversion factor is 1 mole equals 65.39 grams of zinc, okay? And then after you've set this up and mathed it out, you can say if your prediction in 7C was correct. So that's where you decided whether 15 grams was going to be more than 1 mole, less than 1 mole, or equal to 1 mole. All right, I'm going to scoot down, but you should pause and fill out the answers to the rest of these questions that I did not cover. Number 8 says, now go to the balance and measure out approximately 75 grams of zinc. And I have a picture here of 75 grams of zinc. It says record the exact mass here. I had a mass of 76.28 grams. So I was a little bit over on that one as well. It says compare this sample to your reference sample from 7A. Remember, this is our reference up here. Okay. Okay. Based on your observations, would you expect the sample to be equal to 1 mole, more than 1 mole, or less than 1 mole? So that's for you to decide. And then you're going to use dA in a similar way we did before to calculate the number of moles of zinc using the number of grams of zinc from 8A. So that same process that we did right here, but with some new numbers down here, okay? So you can do this part on your own as well. Pause and do that now. It says, now it's time to do something else with this brand new, wonderful, delightful conversion called molar mass. Remind yourself what's molar mass, okay? Then it says, imagine that I wanted you to measure out 0.5 moles of zinc. There's a problem. Moles isn't a useful measuring unit in the lab, okay? In the lab, we measure using grams always. We have to measure using grams in the lab because for moles to work in the lab, a mole changes based on what substance we have. It changes how heavy it is or how much mass it has or how many grams it has based on what substance it is. So instead, we measure everything in grams in the lab and then we convert to moles. We convert or we fix that by using molar mass. Those are those numbers that come from the periodic table. Okay, those atomic masses. And when they have units of grams per mole, like nitrogen, 14.01 grams per mole, then they're a molar mass. Okay? And then C says, so use dimensional analysis and molar mass to calculate how many grams of zinc are in 0.5 moles of zinc. So you have a dA problem here with a start of 0.5 moles, an end of grams, and your conversion factor, again, is going to be some amount of grams are in 1 mole of zinc. And you have that written up above, so go find that. Okay, pause and finish these problems. Letter D says, now go to the balance and measure out about 0.5 moles of zinc, which is blank grams of zinc. That's what you should have calculated up here, okay? So my picture shows you what 0.5 moles is, but you have to tell me how many grams are in 0.5 moles of zinc. And then finally, at the end here, they're saying, okay, now do the same process, but with 1.5 moles of zinc, okay? So you can do that on your own. Pause and do that now. And then when we get down to 11, it's asking us to do some more generalized practice. So now we're not just working with zinc, okay? So 11A says, what's the molar mass of tungsten? I just told you where we find molar mass. So if you don't remember, rewind the video. I told you where do we find molar masses. So go find that for tungsten. And here's a hint. Tungsten has a symbol of W. Then for B and C, you're going to need to do some dimensional analysis. You're starting with 12.31 grams or 4.15 moles. And then you're converting to either moles or grams. And you've got to use the conversion factor that you get for tungsten, the molar mass. Okay? One last set of questions. You guys can do this on your own at this point as well. Converting from moles of silver to grams of silver. So you're going to need some info about silver. Okay, where have we been finding info about different elements? And then same thing with calcium. Okay. Then it asks, why aren't your answers to 12A and 12B the same, even though you started with 5.4 moles both times? Look at your math. Think about the process you had to go through and decide, even though they're both 5.4 moles, why do we have a different answer? Why do we have different amounts of grams? Okay. All right, that was a really quick overview of this lab. You should be able to get this done using the skills that you've learned throughout this unit. If you're struggling with any dimensional analysis or conversions, then you should go back and check out some of my other videos for support on that. Let me know if you have questions.